Welcome. Today we'll explore nanomedicine, what it is, why it matters, how small nano really is, and how nanoparticles work. We'll look at applications in drug delivery, cancer treatment, imaging, diagnostics, surgery, regenerative medicine, the brain, vaccines, and antimicrobial therapy. At the end, we'll do a quick quiz to test your knowledge. What is nanomedicine? Nanomedicine applies nanotechnology to healthcare using particles and tools so small they can work at the cellular or molecular level. This allows doctors to diagnose earlier, target treatments, and even repair tissues in ways traditional medicine can't. Why nanomedicine matters? It matters because it offers precision. Instead of affecting the whole body, nanomedicine can target only diseased cells. This means fewer side effects, better outcomes, and entirely new ways to treat tough diseases like cancer or brain disorders. How small is nano? A nanometer is 1/1000th of a meter, about 100,000 times smaller than a human hair. At this scale, particles can slip into cells, interact with proteins, and influence DNA. The nano world may be invisible, but it has huge medical potential. How nanoparticles work. Nanoparticles can carry medicines, act as sensors, or release signals. Think of them as tiny delivery trucks that know exactly where to go. Some respond to light, heat, or chemicals, making them smart tools that activate only when needed. Drug delivery revolution. One of nanomedicine's biggest wins is targeting drug delivery. Instead of spreading drugs everywhere, nanoparticles release them right at the problem site. This makes treatments like chemotherapy more effective and much less harmful. Cancer treatment with nanotech. Nanoparticles can recognize cancer cells and attack only them. They can deliver drugs or even heat tumors until the cells die, sparing healthy tissues. This targeted approach is already showing promise in clinical trials. Imaging with nanotools. Special nanoparticles can glow or act as markers, making tumors or infections easier to spot in scans. Better imaging means earlier diagnosis and more accurate tracking of how treatments are working. Nanodiagnostics. Nano-sized sensors can detect diseases in the blood at very early stages, sometimes before symptoms even appear. This could make medicine more proactive by catching problems before they become serious. Nanosurgery. Future nanorobots may travel through the body to repair tissues or clear blockages. Even today, nano-coated surgical tools help reduce infection and speed healing. Surgery is already becoming safer with nanotech. Nano and regenerative medicine. Nanoparticles can guide stem cells to grow into tissues or deliver growth factors that repair organs. Tiny scaffolds can help damaged tissues regrow, offering hope for spinal injuries and organ repair. Nanomedicine in the brain. The brain is hard to treat because of the blood-brain barrier. Certain nanoparticles can cross it, delivering drugs directly to brain cells. This opens new ways to treat Alzheimer's, Parkinson's, and many brain tumors. Nanovaccines. Nanotech is improving vaccines by helping the immune system train more effectively. Lipid nanoparticles, for example, were key to some COVID-19 vaccines and may speed up vaccine development for future diseases. Nano and antimicrobial therapy. Antibiotic resistance is a big threat, but nanoparticles can directly attack bacteria or break their defenses. They can even carry antibiotics into bacteria, making treatments more effective against resistant infections. Quiz time. Here's a quick quiz. First question. What is nanomedicine? Your answer could be, it's the use of nanotechnology for diagnosing, treating, and preventing disease. Second question. How small is a nanometer? The answer is 1/1000th of a meter. Third question. Name one way nanoparticles can deliver drugs. Your answer could be by targeting diseased cells directly and releasing medicine only at the site. Fourth question. Why do nanoparticles make good imaging tools? Your answer could be they can glow or act as markers, making tumors and infections easier to see. Fifth and final question. Give one example of a diagnostic use of nanotech. Your answer could be nanosensors that detect diseases early in the blood. Thank you.